Hello, this is Professor Muskan and welcome to my YouTube channel. Today we are going to cover the subtopic related to units and measurements. In our previous video, we have discussed about physical quantities and we have seen some examples related to it. But in this video, we are going to talk about fundamental quantities and derived quantities. So let's see what it is. A fundamental quantity. These quantities are independent of other quantities and they do not require any physical quantity and they do not require any other quantities for their definitions. Such kind of quantities are called as fundamental quantities. These quantities do not depend upon any other physical quantity for their measurements. They are completely independent quantities. So there are 7 fundamental quantities. They are as follows. As we know that they are completely independent, they are length, mass, time, temperature, electric current, luminous intensity. We are going to discuss it about later. Luminous intensity. And the last is but not the least, amount of substances. Amount of substances. So these are our 7 fundamental quantities. That is length, mass, time, temperature, electric current, luminous intensity, and the amount of substance. So let's discuss it further. That what are fundamental units? The units used to measure fundamental quantities are called as fundamental units. I'm talking about the units used to measure fundamental quantities as we have discussed it above. That is length, mass, temperature, electric current, luminous intensity, and amount of substance. To measure all these 7 fundamental quantities, we use some amount of fundamental units. So they are as follows. Length, the SI unit for length is meter. The SI unit for mass is kilogram. SI unit for time is second, whereas for temperature it is Kelvin. For electric current, it is ampere. For luminous intensity, it is candela. Whereas for amount of substance, it is mole. M-O-L-E, mole. So what about its symbols? Meter is represented with the small letter m, kilogram as kg, seconds as small s, Kelvin as capital K, and ampere as capital A, candela small cd, and mole is represented as MOL. So this is how we represent the symbols for the SI units of fundamental quantities. So these are our 7 basic fundamental units. That is meter, kilogram, second, Kelvin, ampere, candela, and mole. So let's move ahead and talk about more about derived quantities. So derived quantities are those physical quantities that can be derived by multiplication or by division of fundamental quantities. It means that we need fundamental quantities to learn about derived quantities. These are those quantities that are completely dependent on fundamental quantities. Such kind of quantities are called as derived quantities. They depend on some or all of the seven fundamental quantities. They are units which can be said as or which can be expressed in terms of fundamental units are called as derived units. Like example, if we talk about, if we take example of velocity, velocity as our derived quantity. So as I said, the derived quantities depend upon the fundamental quantities. We know the unit for velocity is meter per second. Okay, the unit for velocity is meter per second, whereas its formula is displacement upon time. So the unit for displacement is meter divided by time, that is second. So both these unit, meter and second, comes under our fundamental quantity, right? So hence we can say that velocity is the derived quantity. It is our derived quantity. Let's take another example, momentum. Momentum. We know the formula for momentum is mass into velocity, right? So the unit for mass is kilogram into velocity is meter per second. We know that kilogram is the fundamental unit. Meter is also a fundamental unit, whereas second is also a fundamental unit, right? So multiplication of both of this gives our the main result, that is unit for momentum, that is our derived unit. And hence we call this quantity, that is momentum, as a derived quantity, that is kilogram meter per second. This kilogram, meter and second comes under fundamental quantities. Hence we can conclude that derived quantities are dependent on fundamental quantities. Okay, so let's move ahead and talk about some system of units. There are more about it. Let's talk one by one. So system of units. It is a complete set of units, whether it may be a fundamental or a derived quantity. For a physical quantity, it is called as a system of units. So in system of units, there are four types. The first type is about Cgs system. A Cgs system is a Gaussian system of units. Gauss it is named after a scientist named Gauss. Therefore, it is a Gaussian system of units. So, in this, corresponding fundamental units are, as CGS units are somehow related to fundamental units. So hence we can say that it is a Gaussian system of units. In this, corresponding fundamental units can be written as centimeter, meter, and second. Similarly, in MKS system, it is called as a Georgi system, whereas it is correspondingly fundamental units are meter, kilogram, and second. Let's talk about FP PS system. In this system, foot, pound, and second system. The system is known as foot, pound, and second. It is used for the measurement of length. It is used for the measurement of length, mass, and time, as all these are fundamental quantities. Okay. Last but not the least, SI system, the standard international system. It is known as International System of Units. It is applied to the whole physics. And we can say it is also known as the modification towards the MKS system. SI system is the modification towards the MK system, that is meter, kilogram, and second system.